Okay, hello everyone. So many persons have asked me about this assignment, but I don't know how to teach everyone at the same time. So the best way is to just make a video. I thought of that because we are on holidays and not many persons were actually to come to school. So first off, look at the question here. It says, I guess you should just take out your book and look at it. Amino acid analysis of the oligopeptide 7 amino acid residue long gave aspartate, leucine, lysine, methionine, phenylalanine, and tyrosine. So take note. This kind of question is more of logical thinking than how do I put it now? More of logical thinking than solving, like problem solving skills, logical thinking than it's not math, it's not something that you use a formula and solve basically. But you have to be able to read each statement and find what they mean from each statement they gave. So here they gave us aspartate, leucine, lysine, methionine, phenylalanine, and tyrosine. That's six of them. So, but they said the oligopeptide is 7 amino acid long, but it's six elements, six amino acids that they gave us rather. So, what could this mean? This can only mean that one of these six is double. You get, like, they analyzed it and they found out that these amino acids are there. So the only main explanation to that is that there's one among these ones that is double. So we'll find out too. The following facts we observed: A. Trypsin treatment had no apparent effect. So another thing you should understand is to solve this, you have to be able to understand what each element, rather what each enzyme or chemical does. So let's go back to the former class. Trypsin is an enzyme, I think so. Trypsin is an enzyme, and what it solves is trypsin catalyzes the hydrolysis of only those peptide bonds that are contributed by lysine and arginine at the carbonyl side. So trypsin breaks the bond of lysine and arginine at the carbonyl side. So let's give an example. Now I have something like this now: serine, lysine, methionine, and then arginine. So this is the C terminal and this is the N terminal now. Hope you can see what I'm doing. So this is the C terminal and this is the N. This is the C terminal, this is the N terminal. So we have something like this now. If we add trypsin to it, what we will have, where the bonds will be broken will be here at the lysine part and here at the lysine part, because it breaks the bond of lysine and arginine. But it will not be able to break the bond of arginine because arginine is at the end. It only breaks the bond where the carbonyl functional group is contributed. So this is what this place now, this is what it looks like. Lysine contributing the COO group and then the amine of the methionine. So this is the only place it can break the bond, at the point where it contributes the carbonyl functional group. That's the only way it can break the bond. So but it can't break the bond of arginine because arginine is at the C terminal and arginine is somewhat like the COOH. So there is no bond is forming with another amino acid at this point. So it can't break here. So which means if you have this kind of compound, it will not break the bond of arginine, but it will break the bond here of lysine. So here they say the lysine and trypsin was added and it had no apparent effect. So what this means is that and this list of elements you have here, list of amino acids that we have here, lysine is among, and since trypsin breaks the bond of lysine, but lysine is there and trypsin was added, there was no effect. It can only mean that lysine is at the terminal, at the C terminal, because it can't break the bond of anything here. It does not form any bond with anything. So lysine is at the C terminal. So you take note of that fact. So A, for A, let me just give you like the chain of the seven amino acid of the oligopeptide. I mean, 1, 2, 3, 4, 5, 6, and then 7. So from A, we've extrapolated that trypsin and lysine is here because trypsin treatment did not have any effect. So B now, taking it like this now again, 7 of them. So B now, they say phenyl isothiocyanate, which is the Edman reagent treatment, released phenyl isothiocyanate of amino acid residue of the structure below. So Edman reagent cleaves amino acid bond at the N terminal and it cleaves any kind of amino acid at the N terminal. So for this fact that it cleaved the bond, you have to know that whatever amino acid is on this structure is at the N terminal. So the Edman reagent, when it cleaves the bond, whatever is here is going to be the R group of whatever amino acid that is. So the the only amino acid, the difference between all the amino acids is in their R group. Some has hydrogen, some has a methyl group, some different things. So now this one now has CH2 and a benzene ring. So the amino acid with CH2 and a benzene ring at this R chain is phenylalanine. So what this means is that phenylalanine is at the N terminal. Yeah, because phenyl isothiocyanate, which is the Ed reagent, we only cleave bonds at the N terminal. Like the N terminal, which is here, the first element, so which is here. So which means phenylalanine is here. We've gotten for B now. We've gotten lysine here from the instruction A, and phenylalanine from the instruction B. So now let's go to C. So in C now they said brief chemotrypsin treatment yielded several fragments, including a dipeptide, a tetrapeptide, and a tetrapeptide. So take note of the English they use. They said it yielded several fragments. It's not absolute here now. They're telling you that it yielded several fragments, including, which means there are others. It is not limited to dipeptide and a tetrapeptide. So which means there are others. So which means there are other things apart from a dipeptide and a tetrapeptide. So the amino acid composition of a tetrapeptide is a leucine, a lysine, and a methionine. Now a tetrapeptide is 4 amino acid. A tetrapeptide is 4 amino acid. So what this means is that one of these 3 is double. So either leucine is 2, that is 2 leucine, 1 lysine, 1 methionine, or lysine is 2, 1 leucine, 2 lysine, 1 methionine, or methionine is 2, 1 leucine, 1 lysine, and 2 methionine. So that's what it can only mean. So we know that it yielded several fragments. So which means we have to look at the stuff now and try to consider where can this bond be broken to give us a dipeptide, a tetrapeptide, and something else, because they say several fragments including, so there is something else apart from the dipeptide and the tetrapeptide. So I've drawn the stuff again. So we have to check now. Where can this bond be broken? We've established chemotrypsin now is it an enzyme? I think it breaks the bond at the it breaks the bond of aromatic. Get aromatic. So it has to be an aromatic amino acid that before it will break the bond. So chymotrypsin breaks the bond of aromatic amino acid. So and they include tyrosine, tryptophan, and phenylalanine. So these 3 are the only aromatic amino acids. So we have phenylalanine here. We've established that one. We have established that lysine is here. So where can it break among these 2 now? It can break the bond of phenylalanine here, because it breaks it at the carbonyl functional group terminal. So we are sure that this is where it broke for 1, and then this is obviously not using a dipeptide or a tetrapeptide, but this should be the several fragments, because they say several fragments. So now the remaining, now we have to find out. So the dipeptide, we now have to find out where will it break. The bond can be broken. The bond can be broken here. Apart from this one, now this one is gone. It can be broken here to yield a tetrapeptide, which is 4, and a dipeptide. It can be broken here to yield a dipeptide and a tetrapeptide. So now we are in the middle of something. We don't know where the bond will be broken to now know what to fix there. You get? So now let's go to the next one to clear ourselves on that. So the D says that cyanogen bromide treatment yielded a dipeptide, a tetrapeptide, and free lysine. So this one is absolute now. Understand the difference in English. The former they say yielded several fragments, including a dipeptide, a tetrapeptide. So this one now is more absolute. They did not say several fragments. They just give us what it yielded: dipeptide, tetrapeptide, and free lysine group. So let me draw the 7 of them. So it's X, 2, 3, 4, 5, 6, 7. So 7 of them now. And we've established here is PHE and here is LYS. So we established that one. We are not still sure of what this one is. So from here we'll get what this one is. So cyanogen bromine, what does it do? Cyanogen bromine breaks the bond of only methionine. That is MET. That is the only bond it breaks. So it only breaks the bond of methionine at the carbonyl side. So which means from the fact that it yielded a free lysine group, what can this mean? It can only mean that methionine was here to have been broken here and yield a free lysine group. You get, so methionine was here to yield a free lysine group. So now they say it also yielded a dipeptide and a tetrapeptide, a dipeptide and a tetrapeptide. So we've gotten the free lysine group. Now, where will it break to yield a dipeptide and a tetrapeptide? Where will it now break to yield a dipeptide and a tetrapeptide? So now this D now will combine both of them. We'll combine the both of them, combine C and D to get our final result. Because both of them are not independent, they are not absolute. Like you can't find everything here now without going to this one. So we combine both of them. So from this little thing we've done now, we've established that methionine is here. That's why it got a free lysine group. We don't know where the dipeptide and tetrapeptide is. So now I'll relate it back to this one because they say this one, the tetrapeptide was leucine, lysine, and methionine. And we found gotten methionine here. So which means the tetrapeptide can only be from this side. You get? So let me put it back in the C section now. We have methionine here now. So the tetrapeptide can only come from this side, which means the bond that this chymotrypsin broke is here, here, here. You get? So here, a dipeptide here, and here too. These ones are tetrapeptide. The reason why I choose here to be tetrapeptide is because we found out that methionine is here from the D. They say it needed a free lysine group. Cyanogen bromide needed a free lysine group, which means methionine is here and it broke here to yield this free lysine group. So since methionine is here, then we have it in this one that tetrapeptide was leucine, lysine, and methionine. So which means the tetrapeptide has to be 1, 2, 3, 4. You get, it has to be this 1, 2, 3, 4. You understand? So now, how do we go about this now? Now we've gotten methionine. We now have to try to find out which one is double before we can now arrange it. Which one of them is the double? Because you see a tetrapeptide cannot be 3, it has to be 4. So one of them is double. I have to find out which one is the one that is double. And then I'll go back to this cyanogen bromide. They say either a dipeptide and a tetrapeptide. So since we have agreed that this is the tetrapeptide, so which means methionine itself may have broken here, which is here, and then it has also broken a bond here. From this one now, you see, take this thing like it's not just one of the specimen or one of the substance, the amino acid that was used. It's just like they placed this in on 4 different test tubes, and on the first test tube they added trypsin, the second one they added what they add, Edma reagent, then the third one they added chymotrypsin, and on the fourth test tube they added cyanogen bromide. So each of them broke separately. It's not like after trypsin broke, after Edma reagent broke out this place, then the remaining is what they are reacting with. No, everything is complete on different test tubes. You get, on different test tubes, and you have to now solve it and then try to get the sequence from all of them, from the result you got from all of them. So here now, on this test tube C that they added chymotrypsin, the bond broke and yielded several fragments, a dipeptide and a tetrapeptide. So which means phenylalanine is an aromatic amino acid. So it broke here. And then from D now we found out that it yielded a free lysine group, which means methionine must be here for it to have broken here and yield a free lysine group. So which means anyhow, the tetrapeptide that C yielded, chymotrypsin, must be these ones. 1, 2, 3, 4. That's it. So the tetrapeptide that cyanogen bromide now yielded, it has to depend on this C because we found out that the C has leucine, lysine, and methionine. So which means the methionine has to be among of these 4. Yeah, and which means the methionine could be the one that is double because the cyanogen bromine only breaks methionine. So methionine. Now, how do we figure out this thing to yield a dipeptide and a tetrapeptide for cyanogen bromide? And which means, and that the only way is it breaks here to yield a free lysine, and then breaks here to yield this dipeptide and then this tetrapeptide. That's for D. It's not compulsory you must solve C for D. You can see I have to link both of them to be able to figure it out. So it breaks here and it broke here and it broke here. So which means here is methionine. Are you getting? Here is methionine. It broke here to yield a dipeptide, 1 free lysine group, and a tetrapeptide. So we relate it back to this one. We've established that this one is methionine. So methionine is the one that is double here. So now they say from C they say tetrapeptide was leucine, lysine, and methionine. So we've gotten lysine, methionine, and we only have one empty space here. And what does that mean? It can only mean that this place is leucine. And then what again does it mean? If the bond broke here to use this tetrapeptide for the C chymotrypsin, which means we have to be an aromatic amino acid. And from the list, another aromatic amino acid is tyrosine. It's tyrosine here. This is the amino acid that is aromatic tyrosine. So we'll go back here, and which means here will be tyrosine. So we've been able to establish here, here, and here. So the only thing left is now this space. And that is not going to be an issue because we have a list of amino acids: tyrosine, phenylalanine, methionine. They are all there, lysine, leucine. The only one that we have not figured out is aspartate, which means there is no other option that aspartate is here. So you can see you have to link the C and the D to be able to figure it out. It's not compulsory you do it in order. You must not finish A before you do B, and then B before you do C, and C before you do D. No, it's not like that. This A was straightforward, B was straightforward, but C and D had to be linked together. Get it? You want tips that will help you in this sequencing is understanding what each enzyme does and being able to use your brain to think, like find out a way. So when they say this one broke and yielded a tetrapeptide and a dipeptide, so you look at you illustrate it with X and try to find out which side can be broken to give a dipeptide and a tetrapeptide. So like when I drew this one, I tried to find out where can I break, but you know the English, also understand the English. It says several fragments including, so which means it was not just a dipeptide and a tetrapeptide, there was something else. There was something else. So which means the only way is for this chymotrypsin is that it broke here, which we have established to be phenylalanine, an aromatic. It broke here, for that's the several fragments, and then here again tetrapeptide and dipeptide. So I didn't just choose here. If you remember, I didn't just choose here. I was contemplating it can be here too, dipeptide and tetrapeptide, or here, dipeptide and tetrapeptide. So I had to go down to D now to find out which side it was. And here D told me that cyanogen bromide yielded a free lysine group, which means methionine must be here because cyanogen bromide is specific for only methionine. It must be here, and which means the bond broke here to yield a free lysine group. Okay, and then we found out that methionine and lysine are here, and they said the tetrapeptide contained leucine, lysine, and methionine. We have found that methionine and lysine are here, which means there is no way that the tetrapeptide will be 1, 2, 3, 4. It only has to be 1, 2, 3, 4. That's why I now said, which means the bond was broken here, here, and here, here, and here. So that's why I concluded that chymotrypsin broke here and here. And since it broke like this, then this is the 4 that had leucine, lysine. So we found out lysine is here, methionine is here, and then we have to find out where will leucine be now. We only have 2 spaces. Here will leucine and leucine be, and which one is it? Leucine that is 2 or methionine that is double? You get? So I also still use this cyanogen bromide. You say it broke 2, it got a dipeptide, a tetrapeptide, and a free lysine group. So which means it broke here, free lysine group. And then where will it break now? We eventually there is no other place it can break apart from here, because we found out that among this tetrapeptide there is a methionine. The methionine should be the one that is double. So if methionine is among these 4, so which means cyanogen bromide broke here to yield a tetrapeptide and a dipeptide and a free lysine group. So this is where methionine is, and it broke. So we've established here and here methionine. The only option to leucine is the one here. And then since it broke the bond here to read this tetrapeptide for C, then tyrosine must be the one here because it's an aromatic, and then the remaining is aspartate. So that's basically it. I hope you guys understood it, and I don't know, hope you don't have any question, but if you have any question, just feel free to DM me.